Welcome back, folks. Here's another superposition problem. Let's get at it so we can get over it, right? Okay. This one's going to have a current supply in it, so it's a little different, and there's some kind of funny things that happen when you start taking that current supply out of the problem. All right, so let me grab this because we're going to break it into two sub-problems. I keep calling them sub-problems. Because that's kind of what they are. We got to analyze it twice. So I'm going to copy this twice and hopefully leave myself enough room to do what I need to do. I want you to get comfortable restating the problem. How do I take this and find V out using superposition? I see 1, 2 independent supplies. So I'm going to have to solve this problem twice. So I'm going to do it here and then I'm going to do it here. Okay? So let's do it. Subproblem number 1. You can pick either one. I'm gonna start with a voltage supply. We'll just go with that. Okay. We'll go with a voltage supply and we'll replace the current supply with its ideal resistance, which, if you remember from the last video, is an open. Okay, so I remove it and then it just stays removed. Nothing else. Okay, so we've got to analyze this circuit, and now we're looking at the first part of V out. So analyze it any way you want. It actually ends up being, it's going to be 15 volts. Watch. You can use mesh analysis if you want. It seems like overkill in this case, but it is a perfectly good way to do this. Okay, and I would usually ask, how many meshes? Okay, so look at the problem, tell me how many meshes, and the answer to that is, well, there's only one, because this isn't a closed circuit, right? We know the current over here, it's 0, because nothing can flow through that open. It's an infinite resistance. So there's only one current. What's funny is that you can still use the shortcut, okay? You're going to have a 1-by-1 matrix, if you can call it that. We can argue about that some other time. What resistances does it touch? It touches the 10 and the 10 for a total of 20. The right-hand side is going to be any of your voltage supplies over here. And we're going to go up 30. So that's 30 volts. And that's equal to I. Okay? So in that case, it is 1.5 amps. I just did that one in my head. 30 over 20. And look at that. That's a voltage over a resistance, and it's equal to a current. So it works out nicely. It's really just Ohm's law we're doing there. To find V out, I went with orange here. I'm sticking with orange. I made some decisions. That's life. To find the first part of V out, then we take I and we multiply it by R2. Okay, so that's going to be 1.5 amps times 10 ohms, and the first part of V out is going to be equal to 15 volts. Not too bad, right? So it does some weird things. It leaves this resistor hanging out here. You got to ask yourself, is that a mesh? It's not a mesh. It's not a closed path in a circuit. Okay, so we know the current through it, it's 0. Everything else ends up being the same. Okay, let's see. Build our firewall so that we don't get sloppy and reuse our analysis. Subproblem number 2. Let's play the same game. Let's say, what does this supply do to this voltage? So we've got to replace all of the other independent supplies. Right now it's just this voltage supply. We replace it. That's not the eraser. That's the eraser. We replace it with its ideal resistance. For a voltage supply, that's a short. Now we have 2 meshes. Okay, so it's going to look a little different. But we can go ahead and analyze that. If you didn't want to learn the shortcut before, man, I bet you do now. So it's going to be a 2-by-2 inverted and multiplied by a 2-by-1. Okay, so this is going to be 20, negative 10, negative 10, and 20. No voltage supply. Oh, no, 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 no. Go slow. Work the steps. What's your plan? What's my plan? Ha! My plan is I'm going to write one KVL over here, and I'm going to write one KCL over here. Let's do it the right way. Okay, what does I1 touch for the KVL around I1? That's going to be 20. What does it share with I2? Negative 10. And there are no voltage supplies on that side. This one is a KCL. Does I1 touch the supply? No. Does I2 touch the supply? Yes. Same or opposite direction? Same direction, so it's a positive. And then it's whatever's labeled over here. So even though it's labeled negative 3, I can very easily get that in the right spot every time and not screw it up. Because that's my goal, is to not screw up. Okay. So from that, we find that I1 is negative 1.5 and I2 is negative 3. Those are both in amps. Okay. I'm running out of space here. I'm still over my head. I like that. Graphically, not electrically. Okay, so this is I1 equals and I2 equals. I got a little short on real estate over there. All right, figuring out what's going on with V out. Let's say V out. This is the second part of V out. Ooh, I should have labeled that up here. All right, the second part of V out. Okay, now I got to think about passive sign convention. Does I1 touch it? Yes, it does. And it goes in the positive direction according to passive sign convention. Does I2 touch it? Yep. And it goes in the negative direction according to passive sign convention. And we multiply that by R2. Plugging in some values. I1 is negative 1.5 minus negative 3. And we multiply by 10. So what does that end up being? 1.5. That also ends up being 15 volts. Right, because that's negative 1.5, that's positive 3, 1.5 times 10. Yep. 15 volts. Okay, so we can say the second part of V out is equal to 15 volts. All right, putting it all together, that algebraic summation at the end, we can say that V out is equal to the first part of V out plus the second part of V out. Now, both of these examples, they've both been positive, 15 volts plus 15 volts. It is possible that you end up with a negative. I think I have an example that has that in it. And you're just going to take that negative and bring it into this equation in an appropriate manner. Okay? So let's see here. There's your answer. And that's superposition. Okay, so the wrinkle in that one is the current supply. We're going to replace that one with an open when we need to replace it. All right. This scales. We can do it for any number of supplies. When you start working on any signal, you're going to do it with an infinite number of supplies. You're going to do it for a sufficiently large number that approximates infinity. But it does scale. So let's look at our next problem. I think I've got one with even more supplies for you. So stay tuned and good luck.